Assalamualaikum and hello. Today we are going to discuss the application of differentiation from MAT 183 Calculus 1. We are from class J4CEM 1101I and we consist of four members, which is Muhammad Luqman, Iylias Iskandar, Aerreean Ryanhan, and Muhammad Alif Farhan. Now let's start with what is differentiation. Well, differentiation is a branch of calculus that involves finding the rate of change of one variable with respect to another variable. As you can see on the left, the rate of change of function is defined as dy over dx equals f function x. Differentiation shows how a function changes like the rate of change or slope and is used in fields like physics and economics for optimization and rates of change. Now, the few of the many application of differentiation is maxima and minima, related change, mean volume theorem, Rolle's theorem, and determining the increasing and decreasing function. Well, that's all from me. So I'm going to pass to my member, Muhammad Luqman.
Before we get to our problem statement, I'm going to explain why differentiation is applied in this problem. One of the main points is differentiation identifies where the rate of change of the area is zero and confirm this is maximum using the second derivative test. This ensures the rectangle's area is maximized mathematically. Not only that, but also to find the maximum area, we need to locate the point where the area stops increasing and starts decreasing. This is where the slope of the area function equals 0. Lastly, to find the critical point where the rate of change is 0, indicating a potential maximum or minimum. That's all from me. I'm gonna pass to Alif.
Thank you, Luqman. So today we will explore a real-world problem involving optimization. Imagine a farmer who wants to fence a rectangular plot of land that borders a river. Since the river itself serves as one side of the boundary, fencing is only required on the remaining three sides. The farmer has 100 meters of fencing material available. The challenge is to determine the dimensions of the rectangular plot that will maximize its area using the given amount of fencing. This scenario highlights the practical application of mathematical models in problem solving. So, let's find a solution for this question.
Thank you, Alif, and Assalamualaikum. My name is Iylias Iskandar, and today I would like to talk about the solution for the problem that Alif stated earlier. What I have on this slide is a simplified version of what are we doing on this question. So, let me guide you and explain how we did to answer this question through step 1 to 5. Okay, for this step 1, what did we do is we need to understand the problem. We need to define the situation in terms of a mathematical function. So, identify the variables involved and any any constraints. For an example, a specific range of values. And what we having on this slide is let x be width perpendicular to the river. The length along the river is 100 minus 2x since two sides are x each. So the area of the plot is a bracket x equals to x bracket 100 minus 2x equals to 100x minus 2x squared. Okay. For the step 2, we need to differentiate the function. Find the first derivative of the function to identify the critical points. Based on the question, differentiate, we need to get an a prime bracket x. a prime bracket x equals to 100 minus 4x. And for the step 3, we need to solve for critical points. So let me explain. Set the first derivative equals to 0 and, solve for the variable. Ensure the critical points lie within the constraint of the problem. So on these slides, we have 100 minus 4x equals to 0. So after we simplify, we get x equals to 25. So for the fourth step, we need to use the secondary derivative test. In this part, if f prime x is greater than 0, the point is a minimum. And if f prime x smaller than 0, the point is a maximum. So in this question, a prime prime x equals to minus 4, and since a prime prime x is smaller than 0, this is a maximum. And lastly, for the fifth step, we need to interpret the result. We need to verify the solution against the context of the problem. So as we get the function from last step, we got with x equals to 35 meters, and length, we substitute x in the equation. 100 minus 2 in bracket 35 equals to 50 meters. So the maximum area is 25 multiplied by 50 equals to 150 meters squared. And that's all from me. So I will pass back this microphone to Alif Farhan.
Thank you, Iylias. Thus, ensuring the correct identification of the appropriate formula and meticulously calculating both the first and second derivative is crucial for achieving an accurate and reliable solution. That's all from us. Thank you.